Hello all. Uh, Please respond if I am audible or not. Thank you. Okay, so today it will be a problem solving session mostly. So welcome to the live session 2 for this chemical crystallographic course. Yeah. As you all know, that this course is being taught by Professor Anshman Roy Chaudhary from Aiza Mohali, and week two videos are already uploaded, and now you'll be seeing already week three videos have been uploaded also. So the exam date is 28th October. So if you guys want to give to sit for an exam, then you can register for the exam. And I am the TA. Let me introduce first. I am Shani Burman, the PMRF scholar from Department of Chemistry, IIT Hyderabad. Here I am pursuing my PhD in solid state chemistry. I'll be taking the live sessions yeah, yeah, just a sec. Okay, about the fees, I'm not the concerned person, but I can ask the mentor and I'll let you know in the next session. Maybe next session, today is 4th, no? So next session will be on 11th. So it is within the last date time, right? So I'll be letting you know, or you can just raise this question in this uh, NPTEL portal that you are not able to submit the fees. So yeah, I'm not that concerned person. I don't know actually that what's the inner matter. So it's better if you directly contact them, or I will assure you after the like in the next session. Okay, so as I was telling that I'll be taking these live sessions uh, on each Friday 6 to 8, and this is the Jimmy link. Here only we'll meet. So in week two, professor has taught this four or five topics about 2D space lattices, crystallographic point groups, and stereographic projections of those, and space groups and projections of space groups. And he also has shown like six to seven questions in the first tutorial. So today it will be a problem solving session. Now the first problem is these problems I have taken from last year assignments. So let me just introduce. Yeah. So the first question here. So the motif in a crystal is defined as these are the four options. Now let me start with eliminating options. Right. So it of course it's not the symmetry operations. Right. You also know this. Now the smallest repeating unit in the structure is known as unit cell. Right. So it's not the answer. Now, associated groups, atoms or group of atoms, this may be the answer. And 3D array of points with translation symmetry, these are also not, this is also not the answer since it is space group. So the answer will be this. Just a second. Now, the second question is monoclinic crystal system has the parameters. There are four options given. Now, you know that the least symmetric, I'll start as least symmetric crystal system. Like how many crystal systems are there? Seven crystal systems, right? So the least symmetric one is the triclinic one, where A, B, C, neither of them, or alpha, beta, gamma, neither of them are equal, right? Now the second least symmetric crystal system is the monoclinic one. And in this, what happens is A not equals to B, not equals to C, but two of the angles are similar. These are very basic things. These are like bookish knowledges. So you can just go and search in any, like in our video also, or in any textbook, you'll find this. So, which of the following are similar or equivalent? These are the four options. Now, these are all words. These are all screw axis. Screw axis are what? Rotation plus half translation. If you have any problem in understanding, I already gave that example. Like it's like a screw. If this is a screw, and in the like the bottom of the screw is like a spiral one, right? And if you are hammering it uh, in a wooden table, now the screw will go down in this direction, but also it will rotate in certain direction, right? So screw axis is similar. Rotation plus translation, let's say, plus translation will be there. So now one of the easy way to memorize it is, like, let's say the first example, 4 2. So it will give how much rotation? 2 by 4 into 360 degree. You can say 180 degree of rotation plus this half translation. Now 2 by 1. This is also similar. I'm not writing the whole thing. So this will be the answer for sure. Let's do the other ones also. So the second option, l- let me write as B. It is 1/4 rotation, means 90-degree rotation plus 1/4 translation. And in general, we consider as the axis of translation is C axis or the Z axis. Now this, oh, okay. Another option is there. So 4 by 3, also here, 4 by 3 means 3 by 4, means 270-degree rotation plus 3 by 4 translation. Right. Then the third option is 6 by 1, means 1 by 6 equals 1 by 6. Let me write first 1 by 6 translation plus 60-degree rotation. Similarly, for the second option, this one, 6 5, 6 subscript 5, it is 6 by 5 by 6 translation plus 6 6 300-degree rotation. Now, similarly, the T1 is 1 by 3 translation plus 120-degree rotation. And the next one, 3 2, it is 2 by 3 translation plus 240-degree rotation. So the first one is the correct answer. Now, the next question, what will be the equivalent points of in glide perpendicular to A? First, we have to understand what is a glide. So, a glide is reflection plus translation. Suppose this is the one. Now, it will reflect, since it's not the, okay, since it's not the correct, like the end or the final product, I am drawing it as a dotted one, and it will give the half translation along, let's say this is C axis or Z axis, along a certain direction. Now the final projection will be this. So let's say this is C. Now in glide is also similar in a certain direction, and it is also mentioned in the question that perpendicular to A direction, not C direction or what. So for in light, what will you do? Let's say a point. We'll do this is a matrix form, right? So we'll do in matrix formation only. X, Y, Z. This is the initial position. Let's say this. This is the origin, and X, Y, Z point is here. Okay. Now, perpendicular to A direction. A direction means it will go along the A direction, and also reflection will be there. Means there is one inverse or minus sign will be coming, because we know inversion gives rise to a minus sign or a bar, like X bar. This is the bar, right? So if it is first, let's say first we are taking the reflection along this axis. Let's say this is A axis. Okay. Let's say this is A axis. Okay. So it will reflect first, means what will be the answer? X bar, Y, Z. Now the translation, this is reflection, and now there will be half translation. So now for translation, what will we have? We'll have, since it is translation along the like perpendicular to A, means the other two axes will be like like the point or whatever yeah, this you can call it the point. It will translate along this BC axis, right? So the BC axis means the Y and Z axis, the similar B equals to Y, Z equals to C. So along that plane, plus half will be added. So Y plus half, Z plus half. So where is this in option? Yeah, the last one. Yeah. So this will be the answer. Now the next one is Bragg's law of X-ray diffraction. Is you all know that it is n lambda equals to d 2d sine theta, right? N lambda equals to 2d sine theta. Now we'll just see how this is coming. Let's draw these planes first. Let's say there is one crystal or one atom. Mhm. Now parallel to that incident ray, I'll draw another two rays, and these are like the lattice planes, right? And the distance between these two planes are denoted as d, which is interplanar distances. Right. Now this is now okay. Now X-ray is coming, and X-ray is what? Is an electromagnetic radiation. So it will coming like this. Right. Similarly, like this, let's say. Can just remove this. Okay. Now you all know that when X-ray comes and to diffract, now let's say this is okay. This is diagram. So let's say this is diffractometer or the detector. Let's say this there is a detector. Now X-ray is coming. Let's say this is ray one and this is ray two. So since ray 1 and ray 2 coming in this from the same direction, and both of them hit two different atoms in different lattice planes, and those beams or those rays gets diffracted upon a certain angle to the detector, and detector detects it, right? And gives us the like the plot, like we get the PXRD plots, no? Or single crystal PXRD plots. That's so. Now since X-rays are coming, and this is constructive interference is happening, right? You can write somewhere constructive interference is happening. Now, what happens? Uh, okay. Now let's say these are the points. So, can you tell me like if the wavelength of the X-rays, let's say wavelength of the X-ray equals to lambda. So, what will be this much value? First of all, what is this? What do you call this? So this is basically path difference where the phase changes, right? Yeah, these are waves only, but I'm asking this blue thing, this blue difference distance. So this is path difference, and lambda is the wavelength of the X-ray, right? And in the uh, path difference is equals to lambda here. Yeah. So uh, Mm, yeah. And now we have to see if we draw a line here. So the incident beam is coming with theta angle, and it's getting diffracted. How much? If we extrapolate the direction of the incident beam, so we'll see this much value is 2 theta, and this is called 2 theta is the diffracted angle. Okay. Now if this is D, this is D. So if we like draw perpendicular to this, to the ray 2 from ray 1, so we'll get this value as d sine theta, right? Because sine theta will be, let's say this is x, then x by d. So yeah, this is x, then x by d. Then and we also know that you if that from this equation only you can see n value is there. What is n? N is the order of diffraction, right? Now how will you justify it? Let's name this. Let's say this is a, this is b point, this is c point, right? Now you tell me the path difference between the ray 1 and ray 2. What will it be? The path difference, it is actually n lambda. We denote it as n lambda, and n lambda is the summation of AB plus BC. That is d sine theta plus d sine theta equals to 2d sine theta. And HKL values are, let's say these are HK, this is HKL, the first one, the H prime, K prime, L prime. Each plane has different Miller and indices, right? So we just denote the interplanar distance with a suffix of HKL to make it easy to understand which plane we are talking about. So the final answer, as we all know, that it is n lambda equals to 2 the HKL sine theta. Now, the next question is the unit cell having the least volume should be chosen to represent the lattice. Of course, yes. Last class only we have discussed this. Least volume plus highest symmetry. We should choose. Yeah. Now, the next one is the k beta radiation of atomic number Z can be removed by using a filter of atomic number Z plus 1. No, it is actually the reverse one. It should be Z minus 1. Yes, right. Z minus 1. Like if we are using copper, like, okay, we can write it as iron, cobalt, nickel, copper. So, if we are using, if our sample is a nickel containing sample, then the cobalt one we should use as a beam filter. Or if it is our sample is a copper contains copper, then we should use a nickel. Yeah, sorry, the previous one I told wrong. If the sample contains copper, then we should use a nickel containing beam filter. And if our sample contains cobalt, then we should use a iron containing beam filter. Okay, like that. So it will be false. Now the law symmetry of trigonal crystal system. So trigonal crystal. Now you all know that how many crystal systems are there? Seven. Right. So trigonal is one of them, and there are 11 point groups which are known as law symmetry. I'll just write them down. And among these are total 11. And among these, how many are represented in an option? I can see MMM and 3 bar M. Right. So among this, we have to find out that which crystal system, like which one is included in which crystal system. So this is triclinic, which has no symmetry operations other than inversion. Then this is 2 by M, this is monoclinic. Then this is orthorhombic. These are, as you can see, four-fold axis, tetragonal, three-fold axis, trigonal, and six-fold axis, hexagonal. So yeah. So basically, law symmetry, these groups, these point groups, what they like, what do they do when a crystal is, let's say, if the sample, yeah, if an atom or a point, let's say, if it is rotated by 360 degree, the diffraction pattern will give us, yeah, the law groups. Okay, so yeah, this one. And the next one is the maximum of breaking radiation shifts to lower wavelength by using high potential difference. Yes, that's correct. Because, sorry, yeah, because when higher voltage is used, let's say higher voltage is applied, and what do you like? Why do we need to use any potential difference to accelerate electrons inside the X-ray tube, right? Like then in the last class, we have discussed how an X-ray tube works. So in an X-ray tube, if we apply a high potential difference, so electrons will oscillate more, or yeah, electrons will accelerate more. More electron acceleration will be there inside the X-ray tube. So similarly, electrons will release also high energy. Energy release will be maximum. Now, we already know that E, equal, E equals to H nu, right? E equals to H nu, where H is the Planck's constant and nu is the frequency, right? So, so if energy increases, then the frequency also increases, and also we know that it is hc by lambda, means wavelength decreases. So as the potential difference increases, electron gains more energy, and when they strike to the target material, it will also release high energy, right? So these higher energy X-rays have shorter wavelengths. So means lambda will be the shorter. So compare this is lambda is shorter than wavelengths of the X-rays. Okay, I'll just simplify it. So if the potential difference we are getting higher, so the energy release will be more. Now we'll be have the lambda will be less. So we need high potential difference to shift the radiation to lower wavelength. Okay, it's that simple. Now the next one is okay. So the next one is K alpha X-rays have shorter wavelength than K beta. No, it's false, because in that diagram we have seen if K beta is there, K alpha is here, right? This is K beta and this is K alpha, and of course this is lambda, and this is intensity. Now the next one is what symmetries are present in P1 space group. P1 means triclinic crystal system. P1 means there is no symmetry, only translational. If it is P1 bar, then it would have inversion and translation symmetry, right? So yeah, S6 equals to M. No, actually, S6 is equals to 3 bar. So S6, how we have to write S6, like how we can draw S6. This is stereographic projections of the symmetry elements, right? So S6 means there would be a six-fold symmetry. So and S6 means it will be rotation plus reflection, right? Rotary reflection. This is the improper plane of axis, right? So rotation is 6. 6 means what? 6 means 30-degree rotation, right? Sorry, 60-degree rotation, yeah. So it is 60-degree rotation. Here it will come, but it will reflect like within the plane. Let's say this is the plane. So below the plane it will go, and if the symbol or the point goes below the plane, we remark it as a open circle. So we'll denote it as an open circle, and similarly, it will come to this area, and it will come above the plane. So it will be a closed circle. Similarly, this will go here, this will go here, and this will go here. So the opposite thing will only happen. This is open, this is closed. Where did I do mistake? Here it will be, sorry. So here it comes, then here it will be closed, then here it will be open, and then it will be closed again. Yeah. So similarly, if we draw s- simple aim means what? Aim aim means just a mirror plane, right? If it is this, then if the symbol is this, then it will be just this, right? It is as simple as this. But S6, what do we know is S6 equals to or equivalent to 3 bar. 3 bar means we have to draw 3 bar. Now this is a 3 bar means threefold rotation. We'll denote it as a triangle. Now 1, 2, 3. So this is one point. 3 bar means this point will come here. Means firstly threefold rotation will do. Then there will be inversion. This threefold rotation, first it will come here and then it will invert here. Okay, I'll just do step by step. So this one will come here and it will invert here. Right, inversion is going to happen. Similarly, this open circle, it will come here and it will invert. Yes. So it will come here and it will invert here. So we'll have a closed circle here. Similarly, if we'll be having same pattern like the S6 ones. So this is open circle. Now we'll have like this is closed circle. So we'll have an open circle, then closed circle, then open circle. Yeah. So this is same the opposite. So we call S6 equals to equivalent to 3 bar. Now the next question is which among the following space group doesn't have two mutually perpendicular mirror planes? Now we'll just decode each option. So the first one is PBCA. PBCA means what? These are P is for primitive lattice, B for B glide. Now what B glide means? Okay, I'll first draw this A, B, C. Right. So generally what we consider is if it is, let's say if it is C glide, then it will be perpendicular to A. If it is A glide, it will be perpendicular to B axis. If it is B glide, then it will be perpendicular to C axis. Right. It is just like that. So PB is CA. So this means primitive lattice. B glide perpendicular to C axis and C glide perpendicular to A axis and A glide perpendicular to B axis. Yeah. So if this is already perpendicular to axis, and B glides means glide already means reflection plus translation. So there has to be a mirror plane. So already here you can see three mirror planes generating. So this option we can't go. Then CA 21. 21 is screw axis, right? Screw axis we have earlier also done that. Right. Yeah. 2-1. Yeah, 2-1 is 180-degree rotation plus half translation. So here also you can see just like excluding 2-1 also you can see there is C and A glides like glide planes are there means there would be two perpendicular mirror planes. So this can't be the option. Now the third option P 2-1 means 2-1 P primitive lattice then 2-1 screw two unscrew parallel to z axis. Like generally we take z or c axis. So okay, since I'm writing this, I'll be writing. Okay, let me write this as x. This is this is b perpendicular c axis, right? So this will be z, and this would be x, and this would be y axis. So yeah. So two unscrew parallel to z axis. Similarly to two, again there will be another two unscrew perpendicular to y and a axis. Right. So you can't see any mirror plane generating here. So this would be the answer. Okay. Now the next one is a space group 4 by m means 4 by m means fourfold axis parallel to fourfold axis, and the m will be, and the mirror plane will be perpendicular. If this is the fourfold axis, then m will be the perpendicular. So it should be like one the both of this prime principal axis and the mirror plane both will come in correspondence to one particular axis, right? Because this is one is parallel and one is perpendicular. So and generally we take c or z axis like as a standard or the reference. So this third option will be the correct. Now, the next one, whenever two mirrors intersect at a 90-degree, which symmetry elements is generated? So, of course, two mirror planes is a twofold axis. So, if a molecule has one chiral center, it will have to crystallize in one of the chiral space groups. Yes. In, in the lecture video by sir also, it has been mentioned that chiral center, if it is there, means let's say there are A, B, C, D, four different functional groups. If this is a one molecule, then it has to be come in chiral space groups. Now, one more thing I want to add here. You must have seen Sir's video where Sir have mentioned that space groups are two type of. There is one centrosymmetric and one is non-centrosymmetric, right? And among the non-centrosymmetric one, there comes the two types of space groups. One is achiral and then one is chiral. The chiral ones are where no mirror planes are present. Mirror planes means reflection can't happen. So glide planes also are not possible, right? Like P1, P2, P21, 21 means screw axis are present. No M means no M or no A, B, C, N, D, right? This should not be present. The next one is the space groups P1 bar and PM have Z equals to 2. And how we should do that? We have to do it by those equivalent, how many equivalent points are present in one lattice by by that method. So let's draw first. If this is a P1 triclinic centrosymmetric space group, so P1 bar, and for a space group, we denote it as a comma sign, right? So if it is this is the first one, then it will be invert. So it will be like this. So the first point, if it is here, then the second point it will be here. Then the similar thing, the first point, what we do, we draw the first point at in different four corners, right? So we'll get four inversions also. So there are two equivalent points. Z equals to 2. What are those? Those are x, y, z and x bar, y bar, z bar. Now for PM means there are mirror planes are getting generated. So these are mirror planes, right? So if it is here, if firstly we draw at four corners. If it is here, then the next one will be here. The mirror planes, the reflected ones. So here also we are getting z equals to two equivalent points. And what are these? If one is xyz, then one is x bar. Let's say this is uh, generally what we do. We take it as 0 is the origin where the first point is taken. And this is b axis, this is a axis, right? So in the b axis, we are getting the reflected positions. So x bar, y bar, z bar, z just. So these are the two, these are the two. So the space plus p1 bar and pm have z equals to 2. This it is correct. Now the 4 crystallographic point group is equivalent to D4 molecular point group. 4 crystallographic point group means a fourfold rotation, a fourfold will be here. Let's say this is the fourfold. So let's draw it first. Now fourfold if it is getting generated. So if it one point is here, now another point is here, now another point is here, another point is here. Right. Fourfold and like one perpendicular and two perpendicular mirrors. Right. So crystal is equivalent to D4. Okay. Uh, so this is the one point. Yeah. So if mirror is getting generated here, so we'll be getting the same thing here. If this is one mirror, you can say this is also getting generated. And similarly, if it is one mirror, it will generate this four positions also here. Excuse me also. Yeah. So this is one crystallography. Okay, so firstly for this we need to discuss this. What are crystallographic point groups and what is crystallographic symmetry and what is a molecular symmetry? So in crystallographic symmetry we do not have integers. Like for molecular symmetry we have integers. Okay, in the in the notations we should have integers, and for crystallographic symmetry we don't have those. So for D4 symmetry, D4 molecular point group. So can we draw the D4? Yeah, we can draw. So for D4 means there must be C4, right? First, so C4 means a fourfold axis, a fourfold rotation axis. Then it should be having four C2 axis perpendicular to it. If this is the fourfold rotation axis, fourfold, then one, two. Let's say this. I have to remove this one. If this is the fourfold one, then there should be four C2 axis. C2, 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 C2. Right. For four C2 axis are perpendicular to that fourfold rotation axis. And so there will be four. Yeah. So this is the case only. This will be the case only. I think I am right only. And for which cases this mainly happens? If there is a chiral, let's say this is X, If one chiral molecule is here, then or chelating ligand is present, then that should be the example of a D4 molecular point group. Means this is should be in bold. This is should be in bold. Means this is not in directly in plane but also tilted. So this one is one of the example of D4 where this is the D4 rotation axis and two and yeah, four perpendicular C2 axis are present. Let's say this, two, three, and some other will be four. Yeah, like if we rotate this molecule in this direction, then it will give the same for same structure. And if we rotate, these are the C2s, no? If we rotate 180 degree of this molecule, then also it will give the same direction. So the next one is the non-symmetric, non-centrosymmetric space group among the following is non-centrosymmetric. Okay. All are looking like by looking at the structure, you can see that all are centrosymmetric, right? Because all are having bar, like bar on the heads. So P3 bar, P1 bar is triclinic, P3 bar it's also trigonal, R3 bar is also trigonal, and P6 bar is under hexagonal. But P1 bar we already know it's centrosymmetric. P3 bar is also centrosymmetric. R3 bar is also centrosymmetric. Now P6 bar it should be the non-centrosymmetric. Yeah, P6 bar is the non-centrosymmetric. Now what is the space group of the following representation? Okay, so you can see from the notation only that it must be having some this is a translation direction and this is a screw direction, right? So in all the options you are having screw only, here also, here also, here also. So this is not the case, of course. And this is not c-centered. If it is c-centered, there must be some atom here. So it's not c-centered. Here also this option is also going out. Now P21, okay, P21, have we drawn this earlier? P21, so P21 how it will be? If it is this, so P21, this will be, okay, I'm trying to P21. So 21 means like a 180 degree symmetry, a 180 degree rotation plus translation, like a half translation. So 180 degree rotation will be like this. It will be half translation, means this. Yeah, and 180 degree rotation also gives us like an inversion, right? So it will be here. So this is not the case. I'll remove this. It is the case. Now, similarly, if it is like this, we have to draw in four corners as well. So similarly for this one also, it will be here. For this one also, it will be here. Okay, for translation, we give this half arrow. So it will be here. Right. So now we can see one for this point also one glide one yeah one screw axis is getting generated here also. So we can you can say since this is one glide here, here also it is getting generated. Yeah. Similar to this is P21. Now, what will further happen if for P21 so for P21, like 1 to 1 screw axis, it will be perpendicular. Let's say the first one, it is perpendicular to Z axis. Then the second one will be perpendicular to Y axis, let's say. And the third one will be, not sorry, not perpendicular, it's parallel. Parallel, parallel, parallel to X axis. Right. So there will be a two more screw axis is getting generated. So let's say for P21, if the first point is XYZ, then the second point would be to one perpendicular to, let's say, Z axis. It will be to one parallel to the Z axis. It will be X bar Y bar Z plus half. For P2121, the equivalent point will be XYZ and X bar. First one would be the same, Z plus half. Then the second one, let's say it's parallel to Z axis, now Y axis, right? So it will be X Y bar plus half. No, it will be X Y bar plus half plus Z equals to half. So Z bar equals plus, sorry, this will be the whole bar. So we can write it as X Y bar plus half minus Z minus half, or X Y bar plus half Z bar minus half, right? Z bar minus half. Then the next to one will be getting applied. Now it will be, this is parallel to Z, this is parallel to Y. Now this is will be parallel to X. So X will be getting plus half addition. X plus half Y bar, Y bar plus half whole bar, Z bar minus half whole bar equals to X plus half Y minus half, means bar, it will be minus minus cancel. Then Z bar will also plus half. Z bar will also be Z, will become Z, and it will be plus half. So these are the equivalent points you will get. For this one, it's Z equals to 2. For this one, it is Z equals to 4. Means you can say that this space group representation, because in for P21 it is getting generated only at the axis only, but for P21 there will be a generation of screw axis in centers as well. So you can say that this space group representation is for P21. Okay, actually I have connected this assignment, this few questions. I have 20 questions total in today's session. So this is connected from last year's assignment. I guess this year's assignment is submission deadline is 9th August, and after that we'll discuss about that only. Okay, so week 2 assignment is already uploaded. Please do submit that assignment, and week 2 feedback form is also been uploaded. please submit the feedback form. And if you have any queries, you can go to this section. Just one sec. Yeah. You can go here and yeah. See, this is week 2 feedback form is already uploaded, and you can ask any question here regarding the doubt. And the doubt will be solved by the TAs or the or professor. Yeah, the practice. So I have also included in today's section the practice assignment also. And yeah, so the quiz 2 will be discussed after 9th August. I guess for 9th August is also the due date for the first quiz. Yeah, sorry, not this one. Yeah, 9th August only. Let me see for the third week. The 16th August. Okay. So today, the next class will be having 11th of August. So on 11th of August, we'll be discussing the quiz 1 and quiz 2 together. And I have few more previous year questions. I'll discuss those also. Uh, 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 so, and if anyone has any question, you can ask. Anubhashita, that problem you were asking last week, uh, could you solve that problem or it is still creating problem? You can't find the previous year assignments. Those are only for the TAs. So these are only the previous year assignments. So I am already uploading. See, you can. Okay, sorry. I guess now I am audible. Yeah. So previous year assignments are not for the students. It's only for these TAs and mentors. So you can't actually find them, but you can find them in these live sessions if you are joining. And you can also go here in this portal and okay, now this is not here. So after all this if all are done, all the sessions are completed, then also in this portal only, here comes one option as problem solving, like yeah, problems like that. So you can go to that section and you can you can see these videos, or else you can I am already uploading this videos of live session 1 and 2, and the 2 one, this one I'll be uploading now in a YouTube channel, and that is named as okay. Let me write it here. Okay, I'm just writing it. Wait. So, right. So, here my okay. I'll go and here not it is okay. Just I am showing you one thing where you can see this. See, this is the channel where I am uploading all the live session 1 I have already uploaded. So you can go here and you can just go through these videos and you can check this previous year questions.
Shiny, can I ask you some question?
Yes, yes, please.
Yeah. Last time we discussed like you also got the flag like crystals and you are able to different them.
Yes, yes.
Can you please slightly explain me means what did you do in the soft after assign means how did you collect the data? Is there any specific way to collect the data like we need to some put some values and all?
No, we don't need to put any value. We just
Okay.
what did we do? We just like of course here also technicians are there. They only do, but what we do, we just low mount the crystal on the and we put the crystal in the goniometer, and there is some option I was telling last week also, like there is some scan 5 omega 5 to place the crystal stub in a particular direction in the monitor, in the apex monitor, like where the apex software is open, in that monitor you will see one grid type things, and in the center of the grid, that is the prime location for the crystal or the stub where the x-ray is getting diffracted like the perfectly. So you have to make sure that the crystal is in the center, and if it is like sometimes it happens that if it is flake shaped, then some planes are not visible or the x-ray is not getting diffracted properly. So that one, and while collecting the data, what you can do, I don't know like in which space group your sample is in, but what we do
Okay.
generally, ki, first see if we have some idea ki, this crystal or the is, may come in this space group, then we collect the data in that space group. Let's say it is orthorhombic, so
Huh.
we are collecting it in orthorhombic, but and the faith is also coming good and all, then we go for the long run. Okay, and if it is not coming, then we can also do one thing, we can also collect in triclinic space group, because it is the least symmetric, right? So it will give all the projections, so that's
Okay, so we can also set the means space group according to our means according to
desired.
our desire as well.
Yes, yes, you can do that. And
So
for long run also, you can try it with triclinic, and later you can solve it on OLEX. Yeah, you will get
hmm.
the space prepared.
There is like if we put some crystal on the galvanometer, sometimes it also happen like for example, two dimension is good enough. Like if we rotate it to 90 degree and 180 and this 270 and 360 degree, then sometimes happen like the coinometer is not covering the whole space. Some empty space is there, so it is also going to create a problem, right?
Yes, but not much, I guess. Like
Okay.
it's not like covering the whole space in the sense.
Like when I'm putting the crystal on this means goinometer,
Oh,
and we have take the wall diameter is like 1 mm,
okay.
0.1 mm. Okay,
Okay.
and in 0.1 mm, means some part which is slightly smaller than 0.1 mm. So the left and right side is means there is no crystal actually empty space.
Okay,
So
okay.
that's in such way.
It may create some problem. What is the diameter of your crystal? Is it too small? Crystal
Yes,
size.
yes. Actually, each time the weapon is smaller. That's the
Okay,
problem.
okay. Yeah, yeah, that may create
And
some.
in XRD, the peak is highly sharp. There is no sign for the morphosity.
Okay, so you are not you are getting the PSRD data correct, but not able to detect the crystal structure.
Mm, yes. Because we are designing some new molecules, means we don't have even an idea like what kind of structure may have formed previously.
Mm-hmm.
Because it's a metal complex, organometallic complex.
Okay, okay.
Okay, so the flag like each time we're getting flag like and we put it in sample,
If
it is
Sam,
showing 30 hours and all.
it's too much.
It's too much. I know it's too much. Uh,
Actually, sometimes it create problems like for very small crystals. Yeah,
uh,
that
so
creates.
and one more thing, like R value, right? R value should be less than 5.
Yeah, Like
What if my crystal?
while solving, you are asking.
Yes, while solving, it is
Huh.
showing in OLX like
Huh.
our INT value is
Huh.
6.61 actually, which is higher than point 0.5.
Huh. Huh. Huh.
So is there any way to decrease that value as well? Because that percentage is showing it 100%.
Acha, that feet one.
Yes.
Hmm.
And but this R value is showing 0.61, and the and one more thing, the flag parameter is showing 1.8, which is also not possible. It is either 0 or either 1.
Huh.
It's showing 1.8.
Okay, there must be some problem going on. No.
Yeah, means I don't know where to ask. That's why,
Understood.
if possible, you can ask the professor and you can clear my doubt in next section.
So your problem is basically your R in value is also coming greater than 5, right? Greater than point
Yes,
5.
five.
Huh.
Yes, 6.1 you can say,
Huh.
and the flag parameter is 1.8.
Okay. 1 point.
But like that other part, like shift value is green, means is showing the green
Huh.
color zero
Huh.
zero zero, and that 100% it is showing 100%.
Hmm.
But these two values are creating problem. Means I have two crystal. When I am not able to get the data, and for the second one, this is the problem.
Like your R1 and R2 values are exactly double. Like R2 should be double of R1.
Okay.
That
Hmm.
also you check whether, I guess maybe it will also come wrong, like more than 2 or 1.
Okay. If it is not double, R1 should be double of R2.
No, the reverse. R2 should be double of
Oh,
R1.
it's a,
If
okay. Okay. It's
R1 is, let's say, 0.1, then R2 should be 0.2. Like that.
okay. Okay. Okay.
Yeah.
So if like you also refine the data, right?
Uh-huh.
So is there any kind of problem did you face? Like what did you do? How did you refine the data?
In OLEX software only we do. Uh,
Okay.
but we like that
Because
only. Big like according to the parameters and all, and according to
hmm,
the bond distances only. According to that, we only refine.
okay, okay, okay,
Hmm.
okay, okay.
You can.
Please, if possible, you can ask and please
I'll
let me know
ask.
that what can I do for that sample.
Okay.
Okay, thank you.
Thank you.